This is part 2 of the preliminaries lecture series. Here this part we shall undertake a geometric approach to the absolute value operation. Here we will see that the absolute value can be regarded geometrically as a distance function. The absolute value. Now, what the absolute value operation does to a number is it returns the numerical value of the number. So this we write in this complicated form, and I will explain, and we shall explain what it means. So for example, if you see the numerical value of -1 is 1, okay? So in other words, you just ignore the sign. What I mean by numerical values, you just ignore the sign. You just look at, yeah. And so in this case, if you run it through the definition, here x is negative. So notice that if you run it through the definition, you have to then run it through the second line. And so therefore, to get the numerical value of -1, you have to negate what you feed in, which is -1. And so you end up with what you expect, 1. Now, the numerical value of a positive number, so let's say 7, well, there's nothing to throw out. So in this case, it is itself. So provided that the number, so what this says here is that if the number is positive, the absolute value is itself. Yeah. So the absolute value of a positive number is itself. Okay. So this is an algebraic definition of the absolute value, and what we have here is that it has got very powerful properties where we look at 3 of them. The first one is the absolute value of the negation of a number is equal to the absolute value of the number itself. Yeah. Okay. So in other words, negation doesn't change numerical values. The absolute value of a product is equal to the product of the absolute values, and the absolute value of a fraction or quotient is the quotient or fraction of the absolute values individually. Okay, and then we move on to the most important one, and that is the absolute value of the sum or difference is bounded. So it is bounded from above by the absolute value of the summand or the itself. Okay, now let's look at property P3. What we have to look at P3 is that notice that P3 is really saying 2 things. Okay, it's saying that the absolute value of a sum is bounded from above by the absolute value of the summands. And it's also saying the absolute value of a difference is bounded by the absolute value of the terms that are involved in the difference. Okay, this is really what P3 is saying. It's saying so the absolute value of the sum or a difference are both bounded by the sum of the absolute value of the actors involved. Okay, now so far it's been very algebraic, but this is, but when the absolute value is paired with the subtraction operation, it gives rise to a very powerful geometrical interpretation of the absolute value. And when you consider the absolute value of a difference, you see, the absolute value of a difference of 2 numbers can be interpreted as the distance between the 2 numbers. This is the most crucial property that we are going to work with, and I cannot stress its importance ever more, because this is something that we will be using repeatedly over and over and over again. Okay, that this is very, very important, that the absolute value, whenever you see the absolute value of a difference, you immediately flip to a visual mindset and you say it's the distance between A and B. Okay, so let's try it out. Okay, let's look at the numbers -2 and 7. Okay, So clearly the distance here is 9. Okay, 2 from the left and 7 from the right. So let's see if if we do get 9. So the absolute value of the difference, minus 2 minus 7, you see we have a difference of two numbers. Okay, so that okay, let's compute it just algebraically without pure computation. That is the absolute value of minus 2 minus 7, which is minus 9, and that is 9. And this is the distance between the points minus 2 and 7 on the real numbered line. So this is very, very crucial, and I cannot stress its importance more so. And so whenever you see the absolute value of a difference, you immediately hit into distance. Okay, so let's now look at solving equations involving the absolute value. Okay, so they will come in many forms. One of them will say, if they will give you as a known number like d and say find all the x's such that the absolute value of x is equal to d. Well, for this, okay, so to solve this, this simply means that, okay, you can take an algebraic approach or a geometric. We'll take both, and you'll see you'll come to the same answer. What this means is that this forces your x to either be exactly d or minus d. Okay, so it forces it to either be d or minus d. Now let's come to the same conclusion using a geometric approach. Notice that the absolute value of x can be written as the absolute value of x minus 0, because subtracting 0 doesn't change anything. So absolute value of x means that the distance between x and the origin 0 is exactly d. Okay, so here's the origin 0. So the only numbers that is exactly, remember, in a one-dimensional line, you can only run left or right of 0. So you either can go right 0 or left. So therefore, this will force your x to either be d or minus d. Okay, so let's give an example of this. Suppose I ask you to solve 2x plus 5 is absolute value. Solve for which axis does this satisfy? In this case, you basically treat this as a single number, 2x plus 5, like it plays the role of your x. And then what you then say here is that, okay, so this will then force my 2x plus 5 to either be 3, or it will force my 2x plus 5 to either be negative 3. Okay? And then you can then solve the equality, and then in this case 2x is equal to minus 2, or 2x is equal to minus 8, forcing x to be either equal to minus 1 or x to be equal to minus 4. So there we go, right? So now what about another one? What about where you've got an inequality with an absolute value? The absolute value of x is smaller than d. Well, this will then force your x, to be between minus d and d. Okay, this will then force your it will then force your x to be between minus d and d. Let's look at it geometrically once again. Absolute value of x is just nothing but absolute value of x minus 0. So that is the distance between x and the origin 0. So we want the distance between x and the origin 0 to be smaller than d. So this just points to a ball of radius d, because you're looking at all the x's which are within distance d of the origin. So therefore this will force x to be between minus d and d, same as before. Okay, so let's say I ask you solve this equation. 3x minus 2 is absolute value of 3x minus 2 is smaller than or equal to 1. Well, this thing will then force 3x minus 2 to be between minus 1 and 1. You see, d and minus d. And then this breaks into two equations. Okay, so this means that 3x is going to be between, you add 2 on both sides. Now you have to be careful. When you add 2, remember 2 always preserves, adding 2 on both sides preserves the order. So we get 3 and 1. Be very, very careful. And then now here, you see we have to then divide by 3 or multiply by a third, but division or multiplication by a positive number preserves. And so therefore, if I divide by 3, the order is preserved and I get 1/3 x must be between 1/3 and what, 1. Okay, so once again we have an interval or a ball where the solution set is therefore going to be a ball, and the ball actually gives me, so in this case, the ball starts from -1/3 and it ends at 1. Okay, and here it includes it, so it is closed and also includes both 1. So here the ball is compact because it includes both endpoints. Okay. Now the third type we can test you is what happens if your absolute value of x is between d. Well, this simply means that you're looking for all x's whose distance to the origin is bigger than d. This will therefore force my x to be either be larger than d, or it will force my x to be smaller than -d. Okay, so in other words, you're looking at something like this. You see 0, d, and -d. Remember, you can only run left or right in a one-dimensional space. So you're looking at all points to the right and left of -d. Okay, and then this is how we then solve it. Right, now, so keeping in mind this idea, one can actually solve the power of geometry is it allows you to solve the more complicated types of equations involving differential equation, absolute values. So for example, let us look at this one. So if I look at, let's look at this next question. So I want to find the absolute value of x plus 1 is equal to the absolute value of x minus 3. Okay. Now, in this case, I will translate this as a distance question. So in order to do that, I have to change it into the sum. So x plus 1 is x minus 1. And this one is already a difference, so it's good. So this is saying that the distance between x and -1 must be equal to the distance between x and 3. So if I draw my number line, here is -1 and this is 3. So it means that I need to find points which are exactly the same distance from -1 and 3. So notice that the distance between 3 and -1 is 4, which therefore means that I must be halfway between the two to be equidistant. So if I go halfway between, it means it must be distance 2. So 3 minus 2 will give me 1. And notice that here you see I get a distance of 2 and 2. And so this will force then force my x to be precisely 1. Okay, so therefore the solution here is x must be 1 because 1 is at the equidistant from -1 and 3. Okay, so that brings us to the end of our absolute value lecture. And the most important thing to take away here is that the absolute value of a, what is it? So the absolute value of a difference is always taken as the distance between the 2 points on the number line.